Rational expressions. Do you know what a rational expression is? A rational has the word ratio in it. Yup. It's just a fraction. A rational expression is just a fraction. So before we get into the harder ones, let's go back to what we already know about multiplying and dividing fractions. Do you know how to multiply 1/2 times 3/4? Right, it's 3/8. Or what you probably learned is top times top over bottom times bottom. Right, that's just the basics of multiplying fractions. Can we ever do anything that makes our life easier? Like in number 2, what can we do to make our life easier? Yup, 7 goes into 14 twice, and 5 goes into 25 5 times. You remember what that's called? It's not cross multiply. Right, cross canceling. We'll use cross multiplying in this chapter, but this is not cross multiplying. This is cross canceling and getting 2/5. You could also not cross cancel, just multiply top times top, bottom times bottom, and reduce, and you'd get the same answer. What about number 3? What happens when we divide fractions? We use something that I like to call keep, change, flip. Keep, change, flip. What does that mean? Keep the 5/3, change the division to multiplication, flip the 4/9 to 9/4. Keep, change, flip. Then, of course, you can cross cancel, and you get 15 over 4. So all that fraction work is very middle school. You've done that a million times. It's just a quick refresher before we move on to the harder rational expressions. When we have rational expressions, our method is going to be first we factor, then we cancel. And I'm purposely writing factor really big and cancel really small. Everyone wants to cancel. Cross it out, cross it out, cross it out. But first we must factor before we cancel. And then when we divide, we flip the second fraction. And then we factor. And then we cancel. So we flip, factor, cancel. Now, after all that talk about factoring, we actually don't have to factor in number 4. Well, we really kind of are. That's what cross-canceling is, right? It's thinking of 28 as being 14 times 2 and then canceling the 14s. With the letters, I can cancel like y squared goes into y cubed y times, z goes into z to the 4th z cubed times, and just kind of clean it up. X squared y over 2z cubed. And that one's a little bit unique because it only has single terms. Once we introduce like an adding or a subtracting, now is when we're factoring. So x squared minus 25, x plus 5, x minus 5 over 12 times 3 over x plus 5. Then we would say 3 goes into 12 4 times, and cancel the x plus 5s. The whole expression cancels. Not x 5, 5, but x plus 5 with x plus 5. Good. What happens in number 6? Well, c cubed, c squared can have a common factor of a c squared. C plus 6 squared, I like to write as c plus 6, c plus 6. What's c squared minus 36? All right, c plus 6c minus 6, c squared. So all that work first in factoring before I start crossing out, right? A lot of stuff to cross out. I can leave my final answer, c plus 3c minus 6, or I could FOIL it. But on the test, you'll see I'm going to leave mine like that. Wouldn't be wrong if you FOILed it. And onwards we go. How about number 7? X squared minus 4, x plus 2, x minus 2, x plus 3. I see the division, so this is a keep, change, and then flip. Factoring out a common factor of an x, and then x minus 2, x minus 2. Get everything factored, then you can start canceling. So it looks like I get x times x plus 2 over x minus 2. Nothing else cancels. You could distribute the x if you wanted to, but you don't have to. 8's finally got some leading coefficients, so 2x and x. Then it has to multiply to 9, but FOIL to 9. I think that works, doesn't it? It's a keep, change, flip. So 5x and x. Now these are set up to cancel, so you're going to have that as some hints while you're factoring, like 10x squared is probably going to be 5x and 2x, so that things would cancel out, plus 2, plus 3. Then of course I can cancel anything the same top and bottom, and I get x plus 3. What would happen, by the way, if everything canceled out? You remember? Right, if everything cancels out, the answer is 1. Last one, number 9, is what we call a complex fraction, a fraction inside a fraction. So remember that a fraction bar just means divide. So this is b plus 10, b minus 10 over 10. I'm going to run out of room here. Times 25 over 3 times b minus 10. Fit it in. B minus 10's cancel. 5 goes into 10 and 25. So I'm going to get 5 times b plus 10 over 6. And again, I could distribute the 5 or leave it. So these are just very basic examples of multiplying and dividing rational expressions.